Now, using all these rules and understanding the polynomials, we can now factor polynomials for simplification. Okay, so this would be the next section, 1.3, I believe. Factoring polynomials. First, the greatest common factor. Greatest common factor. So for example, if you have two real numbers such as 6 and 2, between 6 and 2, what is the greatest common factor that is divisible to both of them? The answer is 2, because 6 divided by 2 is 3, 2 divided by 2 is 1. So the greatest common factor between 6 and 2 would be 2. Here we are talking about where we have variables. So 6t to the third minus 36t squared, right? You want to factor this. First, between 6 and 36, what is the common factor? What is the greatest common factor which is divisible to both of them? The answer is 6, because 6 divided by 6 is 1, 36 divided by 6 is 6. So it is 6, the common factor. So you write 6. Now between t to the third and t squared, what is the common factor? The answer is t squared, because t to the third divided by t squared is t, and t squared divided by t squared is 1. So 6t squared would be common factor between those two. Now, the first one divided by 6t squared would be what? T. 6 and 6 would cancel, and t divided by third divided t to the third divided by t squared would be t, minus 36 by 6 would be 6, and t squared divided by t squared is 1, so it would be t minus 6. So that's finding the greatest common factor between two terms in a polynomial. Again, you understand this here is a polynomial. The difference between the previous examples of polynomial where you had x's is the variable was x. Here the variable is t. So no problem. It can happen. Clean this so you can see what they did. You already know what the answer should be. It says the term have 6t squared in common. So you take 6t squared out or factor it out, and you will have t plus or t minus 6 in parentheses. Again, if you multiply, if you distribute this into this parentheses, you would get this. So these are equal to each other. Sometimes in factoring polynomials, you have to group them before you are able to factor them. You look at this example. You have mx squared plus mx minus 2x minus 2, right? Well, at the first glance, nothing between the four pieces here, nothing is common. But if you go ahead and group these two together and these two together, you would see that between the first group, mx to the second plus mx, there is a common factor, and that common factor is mx. Between minus 2x and minus 2, the common factor is minus 2. So for the first group, you can factor out mx. For the second group, you can factor out minus 2 and do it that way, right? So when you factor out mx here, it would be x remains from the first one, and since it is the same as this factor, it would be 1. And minus 2, factor out minus 2, it would leave you with x plus 1. Now, between these two, between this one and this one, again you can factor one more time, because the common factor here is x plus 1. X plus 1 in parentheses, x plus 1 in parentheses, so you can factor that out. So you factor it out, x plus 1, you factor it out. It would remain from the first one mx, from the second one minus 2, mx minus 2. Okay, so this is grouping. We will have a lot of examples at the end of the section about this grouping. Continuing with the factoring polynomials. If you have the difference of two squares, the difference of two squares, such as x squared minus y squared. As you can see, that can be written as x minus y times x plus y. Again, if you multiply these two parentheses together, x minus y times x plus y, you would get this one. That's why this would factor out into these two terms. For example, m squared minus 9. You notice that m squared minus 9 is m squared minus 3 squared. So the difference of 2 squared, that's what it is. The difference of 2 squared. One of them is m squared, the other one is 3 squared, right? So this can be factored out as the first minus the second without the square, and first plus the second. So m minus 3 times m plus 3 should be the factoring here. They are equal, so this would equal to this. They're all the same thing. Even if instead of variables x and y, we had real numbers, by the way, we had real numbers, that would still hold. And we saw a real number before. Let me make up something. Let's assume here we have 5 squared minus 3 squared, right? On the one hand, 5 squared I know is 25 minus 3 squared is 9. 25 minus 9 is how much? 16. So what we are saying is you can have this separately written as 5 minus 3 times 5 plus 3. What is 5 minus 3? Is 2. What is 5 plus 3? What is 5 plus 3? 8. What is 2 times 8? 16. So whether it is variable or real numbers, still this equality in this factoring would hold. Continuing with factoring polynomials. If you have the difference of two cubes or the summation of two cubes, the difference of two cubes or summation of two cubes, such as you have here x to the third plus or minus y to the third would be equal to x plus y plus or minus y times x squared minus or plus xy plus y squared. Okay, let me rewrite this. So I'm going to have them separately. X to the third plus y to the third can be written as x plus y times x squared minus xy plus y squared. So that's for the summation of two to a square. Again, if you multiply these two parentheses together, you're gonna get this. So let's test that. So that would be equal to x plus y times this. So x has to be multiplied by everything here, and y has to be multiplied by everything. So let me write it down. X times x squared minus xy plus y squared, and plus y times x squared minus xy plus y squared. We multiply. X times x squared is x to the third. X times minus xy would be minus x squared y, plus x times y squared would be xy squared, plus y times x squared is yx squared, minus y times x minus xy is minus xy squared, plus y times y to the second is y to the third. Now, you're going to see that everything between x to the third and y to the third would cancel each other. And that's how you end up with x to the third and y to the third. So let's see. I have minus x squared times y. I have plus h squared times y. So this one and this one will cancel. I have plus xy squared. I have minus xy squared. This one and this one will cancel. Therefore, what do I have left? H to the third plus y to the third. Right? That's kind of proof of the way you factor out the summation of two cubes. See what they have after this. So here they give you an example. 8x to the third plus 1. You notice that this is 2x to the third plus 1 to the third. So this is the sum of two cubes. So we can write this based on this factoring that you have up here, right? So the first term is 2x. The second term is 1. First term is 2x. So it would be 2x plus 1. And this would be the first term squared. 2x squared would be 4x squared minus xy. 2x times 1 is minus 2x plus y squared is 1 squared. There you go. That's factoring these two, this polynomial, the summation of two cubes. Trinomial. How to factor trinomial? First, how's a trinomial? It's an algebraic expression. You have h squared, you have x, and you have a constant. Now with the trinomial, a lot of times you have to do trial and error and see which one would fits. So here you have x squared minus 5x plus 6. Now the way you think is you want to factor this into two parentheses. So you look at the first term, x squared, and you ask yourself, how can I get an x squared, right? I can have an x and an x. So I put 1x here, I put 1x here. When I multiply h by h, I get the h squared. Next, you go to the last term you have. You have a plus 6. You ask yourself, what two real numbers, if multiplied by each other, would give me a plus 6? Well, one is 1 times 6, both positive, would give me a plus 6. Negative 1 times negative 6 would give me a plus 6. Negative 2 times negative 3 would give me a plus 6. Positive 2 times positive 3 would give me a plus 6. So you have 4 choices. Only one of those is correct. Which one? The one that if you add them up together, you get a minus 5. Okay? So plus 1 times plus 6. Well, 1 times 6 is 6. That's correct for the last term. But when you add them up, you get 7, not minus 5. So that is out of the question. Okay? Let me write these down. I have plus 1 times plus 6. That give me the last term. That's what I'm looking for. That would give me a 6. I have a minus 1 times minus 6. That would also give me a 6. I have a minus 3 times minus 2. That gives me a plus 6. I have a 3 and a 2. That would give me a plus 6. So all of them would satisfy this last term here. All of them would give me a 6. But only one of them, if you add them together, it would give you a minus 5. Okay, let's look. 1 plus 6, that would be 7. So that is not it. Minus 1 and minus 6, you add them up algebraically, it was minus 7. So that is not it. 3 times 2 is 6, but 3 plus 2 is positive 5. Positive 5. That doesn't give me minus 5. Only this one, minus 2 and minus 3, would give me a minus 5. So these are the answers, x minus 3 and h minus 2. That's how you factor. This is what I meant by trial and error. See, that's what I did here. Trial and error. Looking at the different combination, they give me last term, and then which one would give me the middle term also correctly. Let me clean this and look at the slide itself, which will come up with the same answer that I gave you. H minus 3 times H minus 2. There. With using trial and error, I wrote everything down, all the possible combination down, and came up with H minus 3 times H minus 2. Another trinomial you want to factor here. You have 6h to the third plus 27h squared plus 12x, right? The first thing you want to do, you look at the greatest common factor. That was the first thing in factoring we learned. Greatest common factor, right? What is the greatest common factor between the constant 6, 27, and 12? The greatest common factor is 3. Okay? So I write this, I have a 3. Between h to the third and h to the second and x, what is the common factor? Greatest common factor is x. So I factor out 3x. What do I get here? 2x squared. And here, 9x plus 9x. And last, plus 4. So 3x times 2x squared plus 9x plus 4. Now, the parentheses, you need to factor it out. So let me keep the 3x on the outside. The parentheses factor out into 2 parentheses. First, how do we get a 2x squared? I can have a 2x and an x. How do you get a 4? Again, this is where the trial and error comes. You can have a 1 times 4, that would be a 4. Minus 1 minus 4, that would be a 4. You have 2 times 2, that is a 4. You have a minus 2 times minus 2, that is a 4. Only one of these are correct. Now we have to pay attention to the middle term, which should give me 9x, right? So if I put 1 here, if I put a plus 1 here, let me put it down. If I put a plus 1 here with the first one and a plus 4 here, what do I get for the middle term? I get 2x times 4 is 8x, and 1x times x is 1x. 8x and 1x is what? 9x. Well, I guess I got lucky. The first one was the correct one. Anything else you put in there, minus 1 minus 4, minus 1 minus 4, it doesn't come out to a plus 9x. Or even if you put them the other way, put the 4 here and 1 here, still wouldn't come out the same way. So because of this 2, you have to be careful where you put the 4 and a 1. Only this combination would give the correct factoring. And just confirm that they did it correct too. So the 3x is the greatest common factor. They took it out. 3x times 2x squared plus 9x plus 4. And then using trial and error, which is what we did, they got 3x times 2x plus 1 times x plus 4. That would be the factoring of that polynomial. Again, I should remind you that the end of the chapter exercises is into another set of videos called exercises. And also there is a review of each chapter. So add that to your watching videos. This is just a lecture going piece by piece over the material in this chapter.